Hi everyone, welcome to this presentation about Matrikon Data Broker and also Matrikon UA Tunneler, two applications that work together to provide you with connectivity across the enterprise, but also to work with existing infrastructure that you may have in your production facilities, and in addition to new components that are being brought in. For the first part, I will talk a little bit about Matrikon's strategy or view on how we progress with industry as it goes into the IIoT era. And that'll serve as a good starting point for our discussion on what specifically Matrikon Data Broker does. So Matrikon works with all industries, whether you're dealing with mining, solar power or alternative energies, discrete manufacturing, chemical and process industries. And across the entire spectrum, all the companies have something in common. And what is that? Well, they all have an insatiable need and desire for data, to work with the OT data throughout their enterprise. Because as we move into the IoT era, basically everything runs on the ability to work with the shop floor data in each department of the company. Of course, on the shop floor, but also in business and increasingly in the cloud to either perform analytics that feed directly back to the actual operations or analytics performed for business use. So in the past, the challenge with working with OT data primarily centered on trying to communicate between systems, trying to overcome OPC classic challenges like, for example, DCOM, which was a security issue. Also, systems were primarily working on Windows, and one of the biggest challenges was trying to just connect between different third-party systems because they use proprietary protocols. Now, if we go forward, the expectations are that you have much more secure networks, that there's higher speeds, there's more volume of data coming through, and actually people are increasingly concerned about properly modeling the data. So putting it into a structure that is consistent and easy to understand, not only in one application, but when it's being shared between different applications. This is especially important when data is being sent to the cloud, where you have many sources feeding into a single data ocean, and you have to make sense of that data to do something useful with it, to do the analytics, to then get the benefit in the production from those analytics. So one of the issues there is that if everybody invents their own way of creating these models for the same types of equipment or processes, then it's very difficult to figure out which data from one vendor aligns with what data from another vendor, since they might be using different ways of grouping that information together. Today also, we have more operating systems that are being used. Linux is increasingly being brought in, especially when we move into the enterprise area. And of course, there's a challenge of still keeping legacy or existing infrastructure running while you're working with the new infrastructure. So if we look forward, one of the things that are, like I said, the challenges today are that the data management and security are extremely important to ensure that companies and systems are not compromised by bad actors or by malware or just accidental changes in the system. The older systems have to be also brought into the modern era, because you can't just swap out everything that you have on the shop floor in order to use new technologies. People are not used to working with some of the new IT concepts, and that goes both ways. IT is not used to working with OT, the operations side, and operations isn't familiar with IT systems. So there's a bit of a struggle between them to understand each other and to work well together. There are a lot of standards. Some of them are, or many of them are open, but sometimes they are not interoperable. So one open standard doesn't work well with another open standard, and something is needed to bring them together. And of course, as mentioned, we have that IT-OT gap. Now, that's what we need to solve today as companies try to modernize and continue to compete on a global market. But there's also looking into the future. And these are opportunities where, for example, you can use different vendors' equipment, simply plug it into your existing infrastructure and just have it work as it replaces older equipment. Or just a replacement unit, the ability to scale, so sharing the data on not just from a specific part of a plant, but across multiple plants, so you can see what's happening across your whole enterprise. Also, of course, security is greatly being enhanced and better analytics are being done. So there's a lot of benefit for companies if they are able to get the proper OT data base, the base level, the foundation, so that they can build a lot of solutions on top of that and have the system be secure. Okay, so so far Matrikon has been involved with various companies, and if we look at who we've been helping to date, we've been working with things like chemical companies, where they need to either get information from multiple areas in their plant or even to consolidate data from many plants around the world. In some cases, we're working with plants that have companies that have, let's say, 30 different facilities across all the continents, and they're trying to bring this information together. They're actually using Data Broker to scale up and funnel all that information together into a common place where they can work with it. We also work with let's say pharmaceutical companies, similar types of issues where they have legacy systems that they want to bring in, they want to make them more secure, and they're trying to, again, add additional information to the existing data and then share it out so that they can use it more broadly across different departments. We've got food and beverage companies that we work with. There are even, let's say, appliance manufacturers. So this is more towards managing their production process, monitoring what is happening with their equipment. So again, OPC UA being used to track products as they go through their production process, keeping various statistics about each product as it goes through the, let's say, smart production facility. So that is something that they've also been doing. And as well, even more closer to home, which is for Honeywell, things like the N95 mask production, and even technology being used in power meters for sharing data via OPC UA. That is also being used by Matrikon. So our involvement and what we see customers working on extends across every industry, literally around the world. Okay, so if we look at the Matrikon portfolio, primarily our flagship product is Matrikon Data Broker, which is composed of a main core, which sort of does all the heavy lifting of creating a unified address space, providing things like Reverse Connect, which we will talk about, and also additional extensions to it, like MQTT Publisher to communicate that information to the cloud. So an easy translation between OPC UA and sending it to cloud, and also adapters to connect to third-party systems on the shop floor. Now, UA Tunneler is considered part of this suite. We've had it for many years now, but it's important because it's the piece that allows us to do that phased migration going forward. So you can mix OPC Classic and OPC UA together. And then we also have a low-level OPC UA SDK, or software development toolkit, which is used, called Flex, and it is used for by vendors in order to actually create their own OPC UA enabled products. Now, the other side to this is we also have our existing OPC Classic portfolio. So whether it is managing OPC Classic connections, sharing data between them, making it redundant, bringing it all together and using something called Funnel, or adding security to it, and then as well third-party connectors or OPC servers for various types of devices. Of course, we continue to support that, but as we show in the graphic, the idea is to help companies use what they have today, but start to transfer towards OPC UA because it's more functional, it's more secure, and it's frankly easier work with and to sustain going forward. Okay, so that is a brief introduction to our portfolio and how OPC UA and the need for OT data has spread, let's say, throughout the entire enterprise. So next, I'd like to look a little bit closer at the Matrikon Data Broker and what role it plays in the whole solution in the enterprise, and also talk about a specific part of what it does, which is the ability to communicate across firewalls. Okay, so let's go with that. So first of all, when we talk about the enterprise, we have the whole Purdue network model. So we've got the different levels or layers from the bottom, starting with the actual shop floor where you've got your sensors and devices. Then we move into operations or controls, and then operations. We have DMZs for separating the business networks and the OT networks, and then of course going out to cloud. Now, if we look at that, how the information moves between these different levels, we realize that often there are firewalls between different levels. And of course, the DMZs have two firewalls, one on each side, creating sort of a no man's land just to prevent direct connections from the outside world, which is typically connected to the internet, versus the operational networks, which are shielded typically away from access from the external world in order to protect, of course, the production systems. So in order to have a true IIoT or digitalization, business digitalization achieved, what you have to do is have a secure way and meaningful way of sharing data across each level. So for this reason, this is why I show question marks at each step, because somehow you have to address each of those steps in order to build the whole solution out. Now, Matrikon Data Broker does this. It actually has various capabilities all built into it, into, let's say, one package. You don't have to use all of them at one time, but if you need them, you have them, because that's inherent inside the, let's say, the DNA of the product. However, you can only, of course, focus on the particular problem or challenge you're trying to face, knowing that later on you have the ability to grow into other things as you need them, or maybe you won't. That's up to you. Okay, so one of the things then to look at is, now that we know that we want to get through the, let's say, that entire enterprise, what does Data Broker, or MDB for short, what does it actually have to provide to make that possible? So number one, we need the third-party data connectivity. Then we need to have an ability to add data context. So whether that's engineering units or more structured data to identify which pieces of information fit with which subtype of information, so you can build like a structure of how that data relates to each other. We also have the ability to do edge federation. So that means bringing the various data source information into one common address space so that you can work with all the data in one spot instead of having lots of individual address spaces. And then, of course, we have enterprise and cloud visibility, which is the ability to traverse or actually move through the network and to get the information, let's say, out to the cloud. Now, on top of this, I also mentioned UA Tunneler, which is playing an important role because the connectivity to the third-party systems still must somehow be there so that you can use all the functionality that Matrikon Data Broker provides, but have that available for your classic systems. And this is where UA Tunneler comes in. It's the functionality it provides. So together, between Matrikon Data Broker and UA Tunneler, when you bring those together, then you get a full solution that you could use today and also going into the future. Okay, so having spoken about that, let's take a look at the traversing the network and how we do that seamlessly. Okay, so if we go back to here, we say, okay, Data Broker supports all the different, let's say, steps that you need as you try to go through the entire enterprise. But the question is, so how do we handle this box that I highlighted here, which are the various types of traversal through the network, either across a single firewall or DMZs as stated. Okay, so if we were to zoom in on just that part, we could say, okay, well, first of all, if we're using Data Broker, it facilitates communications across a firewall using something called Reverse Connect, which allows you to keep your inbound ports closed on your firewall. So in this diagram, the red firewall that we show, normally you would have to open at least a single firewall port. You'd have to configure the firewall to say, I will allow the OPC UA client that's sitting up above or outside of the firewall to be able to initiate a connection down to talk to the OPC UA server, which is of course sitting behind the firewall. While that's still quite secure as far as setting up, your encryption and only whitelisting that application to call across, it's still not ideal for IT or cybersecurity purposes because you are still enabling an external agent to call down into the shop floor. And depending on how well different applications are written, that may introduce more or less risk. So with Data Broker and using the OPC UA standard function called Reverse Connect, you are able to switch that around to allow basically the OPC UA server to call the client to let it know that it has information or it would like to establish a connection. And then the client uses the connection that the server set up in order to then start talking the way it would normally start talking over the connection that the server made. The effect of that is that now you don't have to create exceptions on the firewall. You don't have to open up that inbound port coming down into the secure area because nobody is actually trying to call into the secure area. The call is coming out from the area through the OPC UA server. Now, if the OPC UA servers that you're using already have Reverse Connect, then basically you don't need Data Broker to do that function because it already can be done by the server itself. Same thing goes for the UA client to accept the Reverse Connect call. However, many systems do not support Reverse Connect, and therefore when you use Data Broker, it facilitates that. It enables them to call out even though they don't have that function. Data Broker does it for them. And the same way on north or above the firewall, Data Broker also can enable the call to accept the call coming from inside the firewall, and then it will notify or work with the UA client in order to let it know that it can establish the connection. Now, if we look at some of the common architectures of how this looks in real world, of course, we have the OPC UA connections that go from top to bottom, but you also end up having OPC classic connections. So components that are in your network. Now, when you're using OPC UA Tunneler, what it does is it allows you to convert OPC classic components to act as UA components effectively because it's translating between them. So originally, of course, if you were just using the plain OPC classic, you would use DCOM, which of course has been shown over time to be very insecure and a bad idea because it requires many ports to be open on firewalls. Plus, if anybody gets onto those ports, they can actually start to control PCs and such. So very undesirable to use straight DCOM. So of course, one of the solutions and one of basically our biggest sellers for our solutions is UA Tunneler, which eliminates the use of DCOM and it allows classic components to talk between each other. However, it still has one, let's say, lacking function because of the time that it was developed, and that is that it doesn't do Reverse Connect. So it still requires one port to be open on a firewall in order for that classic client that sits above to communicate with the server below. So UA Tunneler is necessary to create the OPC UA traffic. That's still important, but now you can combine that with the power of Data Broker, which allows the Reverse Connect. So if you bring together the OPC UA Tunneler, which converts components from classic to UA and then back, and you feed that through Data Broker, what you end up with is an architecture that allows your classic components to use actually OPC UA and to communicate using Reverse Connect across the network. So really that's the ideal solution because you didn't have to swap out your original components, and you are getting the latest method for, or the best practice for, communicating from inside the OT space or the network out to another component or across the firewall. It could be also on the OT network as well. Okay, so that is a great use case that shows how Tunneler, UA Tunneler, and MDB can work together to provide that ability to have seamless OT data access, across your shop floor or enterprise. Now, as it turns out, using Reverse Connect, so the OPC UA Reverse Connect function, it actually has more benefits than just saying you don't have to open up the firewall port. So for sure, that is, let's say, the number one thing we look at. And therefore, in this list of 7 benefits that we can talk about, that is one of them, right? That you're basically able to keep the firewall ports closed, and you can still have communications between a client and a server. The next advantage is that this actually simplifies your networks, because basically you can call out. You don't have to do a lot of maintenance and keep a lot of know-how as far as which firewalls have what exceptions and which applications have to be maintained to be allowed to talk across the firewall. So it basically makes all of that much simpler to set up and to maintain, because you basically call out without having to put any exceptions inside your OT firewall. Okay, it also allows you to overcome an issue that's we call NAT or NAT traversal, so network address translation. If you are translating the addresses behind the firewall or the router, so that basically what's seen externally is a different IP address than what the servers have sitting below. The nice thing with here is that if you're calling from the server to the client first, the client doesn't have to worry about doing proper network address translation to talk to that server, because the server already called the client from wherever it is. So you're reducing, again, the complexity and the issue that sometimes is faced by not having the network address translation done correctly. Of course, this also improves scalability, because as you start to have a larger system and you have less that you have to manage between each piece, each component that's going to communicate, that's just a lot easier to handle on a much broader scale. So again, that helps from an enterprise perspective. And interoperability is another one. Every component that uses Reverse Connect based on OPC UA, that's not a proprietary solution, that's an open solution. So different vendors' products can work together, and therefore you have much better interoperability. And in our case, when you're using UA Tunneler for the classic components plus Data Broker for the Reverse Connect functionality, even components that don't have this specific function in OPC UA, they can still communicate. You can also reduce downtime, because again, when a server or a system goes down and it comes back up, it can immediately call back to the client. So there's more resiliency built that way. And you also have overall better edge connectivity. A lot of times, systems that are mobile or basically intermittently join and leave the network, depending on what your setup is, they may have a different IP address when they come back and connect again. Maybe they're conserving energy, so when they reconnect, they have a different IP address. In this case, because you don't need the client to know what the IP address eventually will be of where the server is, the server, when it comes up and it goes to call the client, it knows what its IP address is, and that's where it calls from, and therefore the client also can communicate with the server. So if you have an active edge or things are changing around on the edge, it makes it a lot easier to keep those communications going. So that's just 7 more benefits of why using Reverse Connect and therefore Data Broker is so valuable. Okay, now let's talk about the enterprise-wide data architecture. So if you are setting up the overall system and you're getting you want to talk down to a particular application. So here we have let's say an OPC server for Modbus, and we have a PLC that talks Modbus, and it's trying to communicate upwards, and it's converted. So it converts into OPC UA. And also on the other side, we have something that already naturally talks Modbus, for example, the adapter. So Modbus data, the Matrikon Data Broker adapter is already talking Modbus to another PLC. That comes together and it wants to talk outwards. But again, if you aren't using Reverse Connect because you've just got Tunneler and just the adapter, now you have to open the firewall port so that the application sitting above can talk down. And again, that could either be a UA client on its own already, or as it's shown above, a classic client that's using Tunneler in order to talk UA and then be able to communicate between each other. So basically, this would not be for those, the IT security police, they would not be happy about this, or not ideal for them because, you're opening up that port. Now, if we turn around and say, okay, well, we're going to put in Data Broker, what it does is it'll bring the information together from both sources down below. And what that does is it also means that information now the clients no longer need to connect directly to the data sources. They collect the Data Broker and they can get information from there. But the added benefit is that now we do have Reverse Connect. So because we're setting up the Reverse Connect, Data Broker facilitates calling out. So the underlying devices, their information can now be sent outwards and Data Broker will initiate that. And therefore, of course, for IT, that is following a best practice. So the information flows freely and it can be sent to the different clients that are going to need it and they can communicate back and forth as required. One additional benefit of this is that you also then, by using Matrikon Data Broker or MDB, can also start publishing things out to the cloud. And again, you are not exposing your underlying system to the cloud. You're using the extension to publish one way using MQTT out to the cloud. Okay, so that's maybe another talk that we can have. But at this stage, all you need to know is that you can use MDB to generate those Reverse Connect calls. And down the line, if you want to go further off of your, let's say, enterprise network, and you actually want to talk out to the cloud, whichever cloud provider you want to use, you can easily do that as well using something called MQTT Publisher, which is an extension to MDB. All right, so that is how you get, let's say, the full solution between your OT and IT networks, and you do that in a secure manner and also out to the cloud. All right, so thank you very much for your attention, and let's see if you have any questions, and talk to you next time.